Hey guys, it's Vince. Today in this video we are going to go over a system unboxing that actually a video was uploaded to YouTube on September 23rd, 2017 under this person's channel, this Prop Slayer Fabrications. And it's very interesting in this video because I've had numerous clients ask me about the CNC systems, and I've seen many of them externally. I've never seen them internally. And I wanted to do this video because, again, there's a lot of things here to really pay close attention to, because I get questions all the time. Why are your systems so much more money? Why are there such high differentials in components in comparison to what they claim to include versus what you include? So what I wanted to do is look at this video because I was curious myself, and I actually reviewed it this morning. And I was kind of shocked what I saw. And after being shocked at what I've seen, I decided to give you guys a forensic view because, again, this is an older video. I would have never disclosed the name typically, but this was already uploaded 3 years ago. And of course, there's no way for me to go in and edit someone else's video. I'm not going to download it and edit it and all that neat stuff. But this is for educational purposes. And once again, you guys are going to be able to easily spot the knot. So what I've done is I've already marked certain points that we're going to review. First point we're going to review is 9 minutes and 10 seconds of the video. So we'll go over to 9 minutes and 10 seconds. Now mind you, this is a plasma system. I'm just fast forwarding right now. So again, he's covering what this package comes with. I believe it said 9 minutes, 10 seconds, and right here. Here is the unboxing of the motors. I'm just going to hit play.
Sorry, and it just made it a mess, and I built a magnetic torch mount for it, and that ended up sometimes catching on the metal. And so these are 620 ounce stepper motors. You can see here everything's all soldered. Right here, that's kind of, actually, I take that back. I don't know if you can see this, but the connections look to actually be butt connected.
Okay guys, this is a mess, and that's just putting it nicely. I don't know what was done here. He's claiming this is butt connected joined. I get questions on cables done like this all the time, and I'm just going to point out the obvious. First of all, I don't know if you've seen it prior in the video. You can see it right here. It's just it looks like the tip of it. This is a terminal block plug. And why a lot of clients, or I should say vendors, excuse me, like to use these is because they're cheap. And of course, it's very quick in their eyes to just use to make a plug-and-play cable without adding another connector. And most connectors in this aspect would require soldering. If it didn't require soldering, it would require a solderless connector typical to my Rev 3 units. Now, as we look at this, you can see this is all one solid mass right here, okay? So, God forbid this is flexed at all, this is going to be under stress pulling leads out from the motor itself. But that's kind of being nitpicky. I know a lot of guys will say, that may be, that may not be. It just depends on how I run everything, okay? But what we see here with these cables, I can tell you right now, these I find to be not even shielded under most pretenses. I'll be shocked if these are actually shielded cables. And the reason I say that is, if you zoom in on the video right here, you can see that the leads coming out, there's no shield drain. Okay, that's the first thing to notice. Second thing to notice, this is a plasma system, and I've discussed this already. All plasma systems require double shielded cables, so we mitigate both frequencies of EMI. Now what's interesting is none of his cables here, let alone are not shielded, are definitely not double shielded. So once again, our price goes up on the system because we have to replace all our cables. And that's mandatory. Okay, but these connectors, these are a complete joke when you're talking about building a commercial grade system, you would never see connectors like this used. This is used to cut corners in pricing so that, again, it looks like you're getting more for your dollar, when in turn what's actually happening is you're cutting back on the labor and costs that they're putting out to produce a system. Okay, this is a soldering mess if this is an actual cable being made. The other factor I want you guys to pay very close attention to, and I get asked this question a lot, is why don't you use cables that are soldered all together to the motor and just have the connector on the end? That's a good question. Let's discuss it. If you do that and you go to run your cable through your cable chain, you have to have a point of disconnect. And under most simplistic terms, you'd want a point of disconnect at the base of the controller and also where the motor is joined to the cable itself. That is the more professional way to do things, because there are times you'd want to disengage the cable. With something like this mass that he has here, he has to disconnect, or not necessarily disconnect, but he may want to remove this connector from the cable to run this through his cable chain, or if that connector will fit through the cable chain, he has to fish all that cable through instead of just having two pieces where the motor itself is mounted to the chassis with the proper connector soldered on or attached with a proper solderless connector, and then once again just fish the cable through, and it's a much easier process. This is a mess. The other thing you have to think about with this, I don't know how long this is in scale reference to the video we're looking at, but if this is fished through a cable chain and there is motion on this giant piece, we don't know how flexible it is, and over time those connections can actually come loose. They can, I mean, we don't know what's under this. Okay, this is to me a mess, and again, I would be very, very, very apprehensive to install this in a cable chain, because God forbid over time, over flexing, these come loose or either arc, and that's very possible, you're screwed. Right here, you can see fraying already because of excess stress put on this heat shrink. So it tells you that I don't know what they were thinking when they did this, why they would come all the way to the base of the motor with that. You're just putting excess stress on these leads. So these are areas of concern. The main area of concern, of course, is the cables. These are a joke. Okay, and this is an area where a lot of companies cut corners to save money on their end, and it looks like you guys are getting a lot more for your money when you're not, because if you factor in replacing all this and the labor involved with that, it is intensive, and anyone who's done it will tell you it's cost prohibitive and it's intensive. So I'm going to hit play now. We'll go on to the next section,
which is probably fine, but depending on the length that I have here, I may end up redoing that.
Once again,
the material.
Whoop. Let me just come back. I'm sorry about that. Let me just fish back real quick. Here's this connector that we were discussing, and once again, you can plainly see it here, and you can plainly see it in this frame right here. And once again, if we look close, you can see there is no shield drain at all used. So these are just unshielded cables. Okay, they're not even singly shielded with mylar foil. These are unshielded cables, and once again, we're basically at square one with once again doing cable replacement.
I don't know if you can see this, but
now what we're going to do, we're going to go back. I'm just taking my placeholder, 14 minutes, 37 seconds. This is really interesting to me. He's going over the parts, 14 minutes and 37 seconds right here. Here's where he's discussing the Cat5 cables, the Ethernet cables that came with the system. And listen closely to this.
Ethernet cable, nothing special. These are going to be straight through cables and not crossover cables, so if you need more than a 25-foot, you just get, a 30-foot or make your own. It is Cat5e non-shielded Ethernet cable.
Non-shielded Ethernet cable. Okay, now listen, I'm going to let him continue, and I want you guys to hear this.
Okay, Okay, so another Ethernet cable. This one's 25 feet as well, and it's also just Cat 5e. Nothing, unshielded on this one as well. So both of them are
Unshielded.
using unshielded. So if you have a high frequency plasma cutter, you may run into issues.
He just said, and I don't know if you heard that, you can rewind the video if you decide to review this yourself. He just said if you have a high frequency plasma cutter, you may have interference issues. Okay, we're going to continue. Listen closely. Matter of fact, I'll replay that a little bit. I'll just rewind it slightly.
So if you have a high frequency plasma cutter, you may run into issues using unshielded cables. It just kind of depends. The hypertherm it doesn't use high frequency, it uses the blowback technology. So
okay, he just claimed that because he's using a hypotherm plasma cutter, which is an excellent plasma cutter, that it's using blowback, so it doesn't use high frequency. Therefore, he basically doesn't have to worry about using shielded cables as far as his Ethernet, or I guess in turn, whatever cables he says. Now, this is interesting because this video was posted September 23rd of 2017. Now, if we come over here, this is on Hypotherm's site, Shaping Possibility. And you guys can look this up right here. Here is the address, and it's called, this actual post blog is called How to Nullify Noise. Now, what's interesting is this is posted on 12/29 of 2015, 2 years prior to that gentleman making his video. And here's what it's discussing is the cutting machine behaves erratically during piloting of the plasma torch. The CNC may lock up, or the torch carriage or beam may lose position and run away. The machine motion is normal in a dry run or manual operation. The high voltage spark required to create a pilot arc in a plasma system is 3,000 to 10,000 volts. Creates radio frequency, RF electrical noise. Noise can interfere with operation of nearby electrical equipment. Earth ground versus noise ground. Right here, everything here is all set. While the earth ground conducts electricity, the noise ground converts diverse RF electrical noise. In the earth, RF noise emanates radially from the pilot arc. They go into the whole thing about that. If not shielded and properly grounded, any component on a cutting machine can act as an antenna picking up RF from the plasma leads and transmitting it to the electronic equipment. Encoder wires, motor wires, THC cables, and CNC cables are particularly susceptible. If these cables and devices pick up noise, they may malfunction, causing erratic machine performance. Once again, if these cables and devices pick up noise, they may malfunction, causing erratic machine performance. So once again, we look at this, and this is direct from Hypotherm's site, direct from the manufacturer of the plasma machine he's using. What's really interesting is noise grounding recommendations. We're going to cover this end on the back end of the video, but you can plainly see here what he's discussing really makes no sense. He's totally contradicting himself, and again, I'm not pointing that out to put this gentleman down. I'm pointing it out because there's a lot of misinformation online. Once again, we don't know. He's got 2,600 views on this video, and this misinformation carries over. And it carries over to lead people to believe, unfortunately, that they're safe in actually investing in lower quality cables, and they're going to get the same performance. It's not going to necessarily happen. And why I say necessarily there is always the mitigating factor that variables exist, that sometimes systems seem to be stable. I'm not going to deny that. I mean, there are times that you can get by and see that an unshielded system, you're golden. There are things that, everything is, you're blessed in a sense. Now, does that happen with plasma machines? Not typically. These robots, and I've said this in so many different videos, they are different animals. When you produce the amount of voltage, I just read direct from Hypotherm's site, many of my past clients will tell you, I tell them all the time, you can cut corners in a lot of areas. Cables carrying signals is not an area you want to cut corners, especially on larger machines. If you're looking to cut a corner, always have your cables at the top of the list as far as your budget, because they are going to cost you the most, because they are protecting the stability overall of the system. Now, as we continue through this, I'm going to go to the next section. Okay, 2116. Now, this is their Blade Runner system. We're going to go to 2116. I can tell you personally that these systems usually run about $2,000. I'm going to go to 2116 right here, right there, and let's play it.
The reason why I want to build another exterior enclosure, I did notice right now that this screw isn't all the way seated. Actually, it's just loose. So I'm just gonna. It's stripped out.
Okay, once again, $2,000, guys. He's got a screw that's loose. Okay, now, again, that sounds like I'm being picky. We'll see. Let's continue.
Yeah, this one is stripped out, so I don't know. I'll look at that later. But over here, you have the Ethercut port that we saw in the mini PC.
Real quick, the enclosure that this system uses is plastic. Let's say it again. The enclosure that this system is built upon is plastic. Okay? Now, how do I know that? We'll continue that through the video, but let's go back to where we were looking at hypotherm, shall we? Noise grounding recommendations. High frequency RHF enclosure, and they're talking about the enclosure to use to either the star ground bus strip or to a ground rod directly. Wire gauge should be 4 to 10 gauge. Stranded copper wire. Run a separate wire from the machine beam, each rail and torch carriage to either the star ground bus strip or ground rod. Again, using 4 to 10 gauge stranded copper wire. Use braided metal shielding to cover the torch leads. The shielding should go from the back of the torch mounting tube to the power supply cabinet, which is grounded. This shielding is very important for noise control. Now, let me ask you something, because, you know, let's just talk like we understand electricity a little bit. How are you going to ground a plastic enclosure? I mean, are you kidding me? I mean, I'm at a point now where I'm seeing this. When noise problems occur, first verify the earth ground is good and check all noise ground connections for looseness and corrosion. PAC systems use water tables in their process, and often terminal strip for ground setup is in an area that is exposed to moisture and heat. Corrosion on these terminals may prevent good conductivity. One loose connection may cause the cutting machine to act possessed. Once again, one loose connection may cause the cutting machine to act possessed. This is Hypotherm's own terminology, posted once again 12/29/2015. Okay, so what we see here, and we're going to play it. This is a plastic enclosure. Now I'm going to go, and this is where it gets interesting. We go to the internal exam. Let's forensically look inside this beast. He's going to open it up right now.
And see on the inside. Okay, so here's the inside. I think that screw that was loose, I think it's just the threads were catching. It was, I think, yeah.
Once again, we know now that we're dealing with a plastic enclosure, fiberglass enclosure, whatever it may be, because we see a brass insert so that it's threaded properly. Okay, we see a lot of metal inside. As we come through here, you can see him explaining things.
This one right here, but this is actually kind of nice because I didn't know if they had these sets. Yeah, they tested a bunch of them and then had them setting around, but this one was just tested not too long ago. So that's actually pretty nice that they do and test them. And I know that these are going to be your...
Now, over here, these are Gecko G251 drives. He'll discuss that in a minute. They used individual Gecko drives, which I'm glad they did. I mean, at least they're picking the correct drives. The one issue you're going to find is that they actually went with individual drives. I have no idea why. A G540 has 4 of these drives inside of it. The only reason that I could see them actually using individual drives is, first of all, it does definitely make this system more complex. I don't even know where to begin with what they've done here. If this guy went to work on this, I don't know where he would start. There's nothing labeled. There's nothing that's actually broken down so an end user can service the system. And there's no doubt in my mind that they proprietarily do this so that you're always liable with them to naturally get the system serviced, which, you know, I understand they're trying to cover their back end. But if you guys are in the field, these systems are not serviceable. Many of you will not be able to service this. And enough said. I'll hit play. You guys can check it out yourself.
They're Gecko G251s. Or actually, I should say that.
Once again, if we look over here, and this is interesting, we see a crimp terminal. We see a jumper then going to this, and we'll see this on a different panned angle. Another thing I want to point out, many of my computer guys will validate this, so you can just search the internet. When we're using ribbon cables, guys, you never want a very sharp bend in any ribbon cable, because the leads inside a ribbon cable are very, very, very thin, and they're mostly carrying signals. So you always want nice, easy, soft bends whenever you deal with ribbon cables. What you can do, if you ever find a cable, a ribbon cable, or a cable for whatever it may be, that's carrying signals and may have a sharp bend to it, heat it. If you heat it slightly, it will actually release, because naturally the PVC, when it gets warm, it becomes softer in condensity, and then you can actually release a lot of the tension on it. So when you see this mishmash of cables on a, once again, multitude $1,000 system, and we continue this, and we continue the forensic exam, you can see just how many of these ribbon cables are being used. And the thing about ribbon cables too is they take up a lot of air mass inside this enclosure. We see a fan here. And with all these ribbon cables like this and not properly put in their place, so to speak, using proper wire management, your air volume goes to nothing. I mean, there's basically no air volume here. And you'll see that as we continue.
This is breakout board for the Gecko G251, and I can't really see.
Right here again, we can see where we have a lead crimped, where it's coming over to. It appears to be some sort of a ground. We have some other solder connections over here. Let me just see if I can stop it.
Breakout board for the Gecko G251, and I can't really.
Now this terminal right here does not even appear to be fully inserted on the conductor right here, nor does this one. We definitely know that to do all of this work of what they're doing here with jumpers and whatnot, I can't understand that. We're seeing a ring connector here where we're seeing a brown lead. So once again, if that's a ground, that's not even the proper color. They are based in Canada, this company. So again, I don't know what actual coding they're using as far as electrical, but that's certainly not it. Not in the U.S. Let's come back. Hit play.
See. Look, I don't know what this card is. Oh, it's a Mesa. Okay, 7i92H is what the Mesa card is to interface with the Ethernet port. So I'm assuming that this goes to another Mesa card.
Okay, so here's our intake for ventilation. Now what I'm curious about is, with this mass conglomeration of crap in the middle of the box, how is that fan going to do its job to properly cool everything? And how is this vent going to properly allow enough ventilation to this system? Now keep in mind, we're talking ambient temperatures of your shop can be anywhere between 85, we'll say, unless you have AC, which you should, of course, dealing with plasmas and CNC in general. Let's say it's climate controlled and you're keeping your shop at, you know, a nice 70 degrees, 75 degrees. By the time you factor in ambient temperature, we're looking at an increase in temperature easily with this kind of electronics in here, and especially with everything being blocked. You've got to be looking at least a 30 to 40 degree increase, and that's just the average ambient temperature inside here, not actually taking into account extra heat produced by each piece of equipment. Because you can see they've got so many different boards in here, he doesn't even know how to identify half of them. We'll see it goes through. The power supply is
anyway.
right underneath right here. You can see the transformer right there.
Here's a stack of relays. Not sure what those are for, but and then the
Now keep in mind also, on top of the power supply is where they decided to mount the drives. And what's interesting with that is, now they're using a linear power supply because you can see the transformer right there. So it does produce a lot less EMI. But that being said, it still produces some. I don't know why they would use a mount, let alone a metal mount, right over it, which is conductive. So I don't know exactly where the thought process was with that. But as we watch this,
you probably can't
that
see
question
it, but
comes
it's
up a lot.
right underneath the stepper drivers. But this, oh shoot, okay, so this is the U-bob, but I do see what looks to be a, oh no, that's definitely their card. So it looks like they're using the Mesa 71928 to interface with their U-bob board, which is a proprietary board designed by them. Oh, and then here, so this is the torch height controller card.
Now guys, have you noticed that none of these boards seem to have a ground? If you look at this, there's no shield drain, there's certainly no shielding here, and we're using a plastic enclosure. So factor that into your pricing. When you guys look at systems like this, and you look at them and they're charging, $1,500, $1,600. I think they were actually selling a system with a computer software. I had a potential client come to me and say, could you build a system with a computer, the software, and the system, the actual controller itself, for like $3,000? And he wanted a plasma system with torch height and all these supposed features that are encompassed in this system. And there's absolutely no way you can do that unless you look at the feature set that comes with this system. Most of it's proprietary, which this board completely is. And again, the build quality. The build quality, I'm not doing this video, and looking at this video and seeing this in the eyes of someone who just spent a couple grand on this system, I would be heartbroken. If I opened this thing up and it looked like this, even if you didn't know anything about electronics, most people would look at this and be like, what am I looking at? What did I just pay for? And I'm just looking at this as an arbitrary overview. Most people would have that reaction. To see that it's coming with a refurbished computer and, just thinking in terms of how out of date we're looking as far as trying to make an all-encompassing package to make end users feel like they're getting so much when in turn they're really not getting much at all. If you're getting a refurbished desktop with an Intel Core 2 Duo, you're looking at a $40 system to run a plasma system that typically makes thousands of dollars a week easily. It makes no logical sense to me. None. Other than to once again give them a higher bottom line. You can check it out for yourself. But as we continue,
everything's really nice and neat. More Ethernet. This isn't Ethernet cable. This is for sure, but this one isn't. And I really can't see.
Now, here's our fan here. We've got this mass. I'm going to play it because he will pan out again.
I'm not going to take it apart that far. Yeah, so that's, I guess that's that.
Okay, we know our fan is back here. What exactly is this doing over here? Because I can't imagine, like I said, you're even going to get the proper cooling into this system. It's just, I don't know how big this vent is, but this is atrocious. I don't even know where to begin with this. And that's why I look at these systems, and when we do direct comparison, this is not serviceable by an end user under normal a normal end user, I'll say it that way. Someone with advanced electronics who understands their proprietary boards and whatnot, possibly. For normal end user in the field, not happening. The secondary factor is components that they're using are proprietary for a reason. The one thing they are using that is openly available is the G251s. Looking at this NEMA enclosure that they're using with a seal, which means you're basically making more or less an oven if this is not being properly cooled, with this small vent and this fan over here, which is of course being suffocated by a inferior air filter that they're using like a mesh. It's not a wire mesh, it's more of a dense fiber filled one. I'm just telling you right now, these are the reasons that you cannot buy plasma systems done correctly with proper grounding, with the proper double shielded cables. If it incorporates a THC with the proper THC and all the cables that require that, you just cannot do it at that level for that price if it's done correctly. And that is the fact. And when I saw this video, and like I said, within the last 2 weeks, I had this potential client come to me and ask me about these systems, and this actually popped up. I was shocked because I couldn't believe I was able to see inside one of these. And that was the first thing I asked this guy to do. I said, you know what, call them, see if they'll show you inside their system. Well, here's what you're buying. And again, I've never seen inside this unit till this morning prior to me doing this video. And now you guys get to see what you get. This is what you get. And again, you got to look at these things. And to look at this in the eyes of hypotherm, and I've done a distinct PDF overview from Lincoln Electric as well, regardless of which one you love. Hypotherm and Lincoln Electric, both excellent companies. Again, I'm a little more, I have a preference more towards Hypotherm, but overall, when it comes to grounding, when it comes to EMI, these companies cover it exclusively. And seeing this, and seeing what's being said here, and I mean right in their own website, where they're talking you to ground the power supply cabinet, which in this case, of course, power supply cabinet would be his whole damn enclosure. You can't do it. You can't do it. And I don't understand when we see this kind of stuff, why, I always ask myself, why can't other people identify this? But it seems like more and more it's just becoming rampant, where I get questions like, why can't you do this? Why is it that you can't pick up what this is? In terms of how are they getting a better value? I'm getting a better value from them than you. How is that possible? And it's like you're comparing apples to oranges. And I'm glad that a video like this was produced, because now you can see the truth. You're not seeing GX16s. You're not seeing a metal enclosure. You're not seeing a proper EMI dipped enclosure so you can dissipate EMI at a different level. We can produce more close to a Faraday cage effect. Most of these guys, like I said, they're looking for turnkey profit. They blind you with smoke and mirrors as far as what feature set the unit has. Whether it incorporates stability, we don't know. Again, this video is ended. It's September 23rd, 2017. Once again, he hasn't done a follow-up that I've seen. I'll have to check his channel. I mean, I've seen this and it caught my eye, and that's exactly what I watched. But looking at this, I think it says enough. And like I said, you guys be the judge. You can see all of the information I've put out, and my information is taken direct from the largest manufacturers of plasma systems in the country. So if they tell you to do it, there's a reason. And again, there's also a reason why their systems are $50,000, $60,000, because of the engineering involved. And I can tell you, this is not the engineering that they use. So looking at this, hopefully you guys, once again, one of you will be careful. And that's all I'm saying. I have never used one of these systems. This thing may work perfectly. I have no idea. But I can tell you, dealing with this on a day-to-day basis, the internet does not sleep. As an engineer, this is not something that I would put my money into. That's my own personal opinion. You guys, you make your own choice. Once again, I'm just giving you an overview of what you can ask yourselves these questions, and do your due diligence, do your research. Once again, all I did was put in hypotherm, and I put in right here, boom, how to nullify noise. I just put in EMI, and this popped up in Google. So you can then come right over here to the address and check it out yourselves. So guys, be careful. There's a lot of money out there in terms of what you can make with these systems, but by the same token, don't cut yourself short. Don't be penny wise and dollar foolish, because I'm telling you now, going through and rebuilding this system is an entire rebuild. If you were to change the enclosure, just changing the enclosure, think of the work involved messing with this. Okay, and I've had clients ask me that. I've had guys go in and be heartbroken. Oh man, I've spent all my money. How do I do this? They have to go in and rebuild the system from scratch. It is a pain in the ass, to put it mildly. So please be careful. Holiday season's coming up, so I wish everybody the best. Again, the shop has been very busy. Everyone has been really, really great with lead times as far as working with me, and I really appreciate that. To my subscribers, guys, I love you. If you need to get in touch with me for questions or quotes, once again, my email address is storm2313@gmail.com, or you can message me through my eBay store. I'll put the link in the description below. You'll see it on the screen as well. Thank you all for your support. Take care.